Hello and welcome to this video on struct padding in C and C++. Struct padding is an important concept in programming that can help optimize memory usage and improve program performance. In this video we will explore what struct padding is and why it is important and how it works in C and C++. Maybe there is a note, it's only really important if you really care about saving every little tiny bit and byte. If you want to write a regular desktop application and you don't really care about saving a few bytes in a struct variable, then this is maybe not that important. Nevertheless, what is struct padding at all? Struct padding is a technique used to add extra bytes to a struct in order to align its element in memory. So struct padding is adding artificial memory in our struct. This alignment is important because it can improve the efficiency of memory access operations on certain hardware architecture. When a struct is declared in C++, the compiler automatically adds padding bytes between its elements to align them correctly. To understand why struct padding is important, let's consider the following example. Suppose we have a struct with two elements, an integer assuming a 4-byte integer, and a character assuming it's a 1-byte. If the integer element is not aligned on a 4-byte boundary, it could cause performance issues on architectures that require 4-byte alignment for memory access operations. In this case, the compiler would add padding bytes to align the integer element on a 4-byte boundary. Let's see an example. Consider the following code snippet in C++. But the same applies also to C. We have a struct example with the first element is a character, which is a 1-byte variable, and the second is an integer, as I said, a 4-byte variable. We would assume that the struct has a size of 5 bytes because 1 plus 4 is 5, quick math. However, the compiler will add 3 padding bytes, thus the integer will be aligned on a 4-byte boundary, as I said before. So if we print out the size of this struct, we will see this size is 8 because we have 1 plus 4 for this char and int, but also since we have added 3 padding bytes, we have 8 bytes in total for one variable of this struct. The amount of the padding bytes depends on the size and alignment of the elements in the struct. If we would have, for example, a struct with a character and a double value, and the double value has a size of 8-byte, the double value must be aligned on an 8-byte boundary. So there we would add 7 padding bytes. In general, I would say you should list the largest data types at first in a struct and also consider of shifting some elements such that the compiler doesn't add unnecessary padding bytes, let's say. So if we would go from this struct and reorder it to this struct, we would save a lot of memory. Imagine we want to create thousands of variables of these structs, then we would save a lot of memory, obviously. So you should consider reordering your variables in a struct such that you can be as efficient, memory efficient as you can. It is important to note that the padding that is added may depend on the compiler and the architecture you're using. And as a homework, you can think about how you can reorder this struct that is currently shown to reduce the amount of memory that is needed. If you want to learn more about C, C++, and Python, I have a great deal for you. You can look into the video description. There I've listed my Udemy courses on a sale for you. And also, I would be very glad if you leave a subscription here on YouTube, and we will see us in the next video. Bye bye.